Welcome to topic number 34 in Richard James Mathematics Resources. This one is entitled Angles of Elevation and Depression, and this is the third topic in trigonometry. Although I have never heard it said particularly about this topic, students have expressed the fear of hell for topics that do more than require that they apply the principles they have learned in the previous two topics. Here and afterward, the knowledge acquired and skill developed in Trigonometry 1 and Trigonometry 2 will be applied. I hope that you do not believe that the heights of all of the world's tallest mountains were determined by someone measuring them with a tape measure. Oh, they got the height from some device in some aircraft that tells them the height. It might surprise you to know that the heights of some of those mountains were determined before such devices were invented, and also before anyone was able to ascend some of them. How were the heights determined? By using the horizontal distance, the one that is easier to measure. Then calculate the height by making use of the angle of elevation. A person on top of a building whose height is known, hardly likely that there is any building erected without a knowledge of its height. So someone who is on top of a building whose height is known may be able to determine the horizontal distance of an object from the base of the building by making use of the angle of depression. The angles of elevation and depression are always given relative to the horizontal. The angular measure of the inclination of a line to the horizontal, and if that is measured in an upwards direction, so it is an upward direction, it is called the angle of elevation. So there's your horizontal, and there's your line that is inclined to the horizontal, and that is your angle by which it goes up. So it goes up from the horizontal like that, as the arrow there indicates. So that angle is an angle of elevation. So the angular measure of the inclination of a line to the horizontal in a downward direction is called the angle of depression. So here, there's your horizontal, and this is your inclined line, and the angle is going down like that, and that is your angle of depression. The angles of elevation and depression are alternate angles, and some of us call them Z angles, and therefore they are equal. So the angle of elevation and the angle of depression are usually equal. The angles of elevation and depression can therefore be used interchangeably. Some students do not want to use angles of depression at all. It causes them to be depressed. Therefore, when solving a problem, the angle of elevation is always used. I recommend that students use the one that is more convenient based on the diagrammatical interpretation of the problem. This is not really a new topic. As far as its relationship to trigonometry is concerned, it is business as usual. It is the interpretation of the problem that will be of some concern. Now we have our first problem, and we are going to take it step by step. So we have our point, and the point, if you take a look at what is happening here, I'm indicating here every single stage of the problem. So we are interpreting the problem. Let us read the problem first. From a point on horizontal ground, the angle of elevation of a pole is 30 degrees. If the point is 20 meters from the base of the pole, find the height of the pole. So we say from a point, and there's your point, and the point is supposed to be on horizontal ground. Right, so on horizontal ground. The angle of elevation of the pole is 30 degrees. So let's do that. Right, so the angle of elevation is 30 degrees. The angle of elevation, this is your line, and we are moving from the horizontal and up in horizontal in an upward direction. And that is how we know that that's our angle of elevation. And they say 30 degrees. So we have the pole right there. The angle of elevation is relative to this pole, and the pole is indicated right there. And we say that it is 30 degrees, right? And our 30 degrees shown right there as the angle of elevation. Now it says if the point is 20 meters from the base of the pole, so we have 20 meters from the base of the pole. Here's the point, the base of the pole, 20 meters. So we're going to find the height of the pole. So we need to determine the height of the pole, and that is h. How do we do that? There's no doubt that we have a right angle triangle right there. So if we have a right angle triangle, that is your good friend, and we may move merrily along. There you have your favorite, your right angle triangle. The horizontal ground and the vertical height of the pole are 90 degrees to each other. So the ground and the pole are 90 degrees to each other. So you have a right angle triangle. We need to find the height of the pole, and it is opposite to the 30 degrees. So this is 30 degrees, and the height of the pole is opposite to it. So usually this is how we indicate our opposite, with the line going from the angle to the opposite side. So this is your opposite side, which is the height. And we need to make use, because if we are going to be using trigonometry to solve a problem, we need to make use of the information that we have there already. So according to what we have there, we have an angle here that is known. So the height is what we need to know. What is the relationship between the height and this angle that we have right there? The height is opposite to it. The height is opposite to that angle. And we need to make use of other information that we have. So we have a line right here, 20 meters right here. So what do we know? The horizontal ground is adjacent to the angle. So this is the adjacent. The adjacent that we have right there is 20 meters. So we have adjacent and we have opposite. Bearing in mind that this is the angle that we are doing our work relative to. So what is the trig ratio that has opposite and adjacent? That's tangent. So tan of 30 is opposite over adjacent, and we're going to put the opposite here, which is h, and the adjacent there, what is 20. So we need to just transpose this. So we have h, we need to make h the subject of the formula, and this 20 will come over there. So we are dividing here by 20, we multiply by 20 right there. So we have 20 tan 30 is equal to h, and of course we know tan 30 can be determined by using a calculator or mathematical tables. And h is equal to 11.6 meters. So that's all there is to it. One will want to be a little imaginative and design a weird looking problem that may include the hypotenuse. However, this is infrequent in practical situations. Most problems that include angles of elevation and depression usually make use of the tangent trig ratio only. Here we have another problem. The eyes of a man are 2 meters above horizontal ground. He is standing 25 meters away from a palm tree. If the height of the tree is 10 meters, what is the angle of elevation of the top of the tree from his eyes? So there's a man standing, and they have the horizontal is 2 meters above the ground. So he's standing 25 meters away from a palm tree. And there's your palm tree. He's standing 25 meters away from that palm tree. If the height of the tree is 10 meters, we have the height of the tree is 10 meters. What is the angle of elevation of the top of the tree from his eyes? So let us look at the angle of elevation now. We are going to take the angle of elevation from right here, and it is going to go to the top of the tree. So the line is going to go from his eyes to the top of the tree. Good. And that is your angle of elevation, alpha. So our situation is that we have a right angle triangle again. The horizontal is 2 meters above the ground. The triangle in question is also above the ground. So the triangle that we are talking about is this one. Remember that the angle of elevation is taken from his eyes. So this is where we are going to have our angle of elevation, right at this point, which is this angle right here, indicated right here. And this is the horizontal, and this is the inclination line that shows the inclination of the top of the palm tree from his eyes. And of course the triangle is completed on that side right there. So that is your triangle, this one that we have right here. Good. We have that highlighted so everyone can see. The height of a triangle is the difference between the tree and the height of the man's eyes. So this is the tree, the height of the tree, and this is how high his eyes are from the ground, 2 meters. So this part of the triangle is going to be the difference between this 10 and 2 that we have right here. So that is 10 minus 2, which is equal to 8 meters. So that is 8 meters that we have there. So we are going to be looking at this now. We have 25 meters. Of course, if from here to here is 25 meters, then from here to here is 25 meters also. So we have a triangle, a right angle triangle, and this, what we have over here, is opposite to this angle that we need to find. And of course, this part that is 25 degrees is adjacent. So we are talking about tangent again. And the opposite is 8, and the adjacent is 25. So we have tan alpha is equal to 8 over 25. And when that is found, we know what to do. If we have the tangent of the angle and we need to find the angle, we do tan inverse. Right, so that gives us 18 degrees. Tan inverse of 0.32 is equal to 18 degrees. And that's the angle of elevation. A logical approach to this problem requires that the candidate realize that the triangle to be solved does not have its base on the horizontal ground. Being 2 meters above the ground, and with the palm tree being 10 meters tall, the height of the triangle will be the difference between the two. The tangent ratio is also applied. Now our problem, a man standing on Bogue Hill at a height of 1,200 meters above sea level observes a fishing boat, and of course we imagine that it is on the sea at an angle of depression of 43 degrees. What is the horizontal distance between the man and the boat? So let us take it step by step. A man standing on Bogue Hill, there's Bogue Hill, and that X indicates the position of the man. And the height above sea level is also given, and the sea level is placed there also, 1,200 meters, and there we have also the level of the sea. Observes a fishing boat, right? So he observes a fishing boat at an angle of depression of 43 degrees. So we imagine that the angle will go down from this horizontal. Depression goes down from this horizontal. There we have it. So this is our fishing boat, and the angle of depression 43 degrees. And let's see what is to come next. What is the horizontal distance between the man and the boat? So that is what we need to find, the horizontal distance, which is this distance that goes all the way across like that. That is what we need to find. Some students may want to make use of the angle of elevation instead. So instead of using the angle of depression, some students will prefer to use the angle of elevation. So we're going to be using the angle of elevation, and we know that there are alternate angles. So this angle is also 43 degrees. Now, if we're going to be using this angle, we have this height as 1,200 meters, and this is the distance that we need to determine. This 43 degrees is opposite to this side of the triangle, or it may be more appropriate to say that this 1,200 meters that we have on this side is opposite to the 43 degrees. So we know that we are talking about opposite. And of course, this distance that we have here, D, is adjacent to the 43 degrees. And therefore, we are going to use opposite and adjacent, which requires the tangent trig ratio. And of course, opposite over adjacent means that the opposite is 1,200. We have 1,200 over D. 1,200 over D, and that is equal to tan of 43. Now, some students are quick to write answers, and they say 1,200 times tan 43, and they get that wrong. So, what do? This D is divided on the right-hand side, so we multiply on the left-hand side. Then we have D tan 40, which means D multiplied by tan 40. So we need to get rid of this tan 40, so we're going to divide by tan 40 on the other side. And then we write the value of tan 40, which is 0.933. And we complete our calculations like that. So D is equal to 1,286 meters. Notice that the height of the man did not figure in the problem. This is because the height of the man is negligible when compared with 1,200 meters. A man 2 meters in height would not have affected the calculation of D significantly. There's a problem. Let us read the entire problem first. A man standing 40 meters away from UGI building observes two angles of elevation. They are 62 degrees and 60 degrees, and they are related to the top and base, respectively, of a flagpole that is located on top of the building. What is the height of the flagpole? So a man standing 40 meters away from UGI building. So the man is going to be standing here 40 meters away from, and this is UGI building. Observes two angles. So we're going to have those two angles coming in. Observe two angles of elevation. Of course, they are required to go up from the horizontal. And we need to say that those angles, one is 62 degrees and one is 60 degrees. And here we have our flagpole located on top of the building. So we need to find the height of the flagpole. The height of the flagpole is given as h. Now, h may be found by finding the height of the building, h1. So h1 is going to be the height of the building, and subtracting the result from the height of the flagpole and the building together. So, in order to determine the height of the flagpole, remember we have the angle of elevation. We have two angles of elevation. One goes to the top of the building, and one goes to the top of the flagpole that is located on top of the building. So it is appropriate then that we find the height of the building and find the height of the flagpole and the building together. When we have those two results, we may subtract the height of the building from the height of the building and the flagpole together, and we'll end up with the height of the flagpole. So opposite over adjacent is equal to tan 60. So we are talking about this first triangle that contains h1. This first triangle here, this smaller one that contains h1. h1 is opposite to the angle 60 degrees, and 40 meters is the adjacent. It is adjacent to that. So h1 over 40 is equal to tan 60. So of course we're going to multiply, since we are dividing by 40 here, we multiply by 40 on the other side. That's what we have right there. So tan 60 is 1.73, and we make light work of the calculation. Now we need to find the other one. So instead of going through all of the charade and having to write the formula again and do our transposition again, we just go straight ahead and write h2 is equal to 40 tan 62, because it's going to be analogous to the one that we have just calculated. And the first one, h1, is 40 tan 60. So the next one should rightly be 40 tan 62. And tan 62 is 1.88. So that is equal to 75.2 when we multiply this and this together. Now the height, which is going to be the height of the building and the flagpole together minus the height of the building, turns out to be 6 meters. So that's the height of the flagpole. Contrary to what we always do, the original expression was written in the reverse. This causes the unknown to be in the numerator on the right-hand side. Transposition is quicker. The height of the man is insignificant because it affects H1 and H2 in the same way. The effect would have been nullified when the values are subtracted. So the value, if the height of the man was included, when you subtract the value of H1 and H2, since the height of the man would have affected both of them in the same way, then in the subtraction, the height of the man would have been cancelled. And of course, we mentioned about how we attempt to write our formula when we are solving trigonometrical problems. We always choose to write the unknown in the numerator on the left-hand side, and that causes it to be easy to be transposed. If it is in the denominator, sometimes you cannot avoid writing it in the denominator. If it is in the denominator, then you put it in the denominator on the right-hand side, and that will cause the transposition to be easier also. Some students may want to solve the problem by subtracting the angles and using the result along with the 40 meters when calculating the height of the flagpole. Such a move is not entirely incorrect. However, it is not applicable to large angles like 60 degrees and 62 degrees. It is applicable only to very small angles, and the values should be given in radians and not degrees.